Hello! How you guys doing? Let's see, we got 12, 13 of you in here. Come on. Get in here, all you wonderful people. So the live stream looks healthy today. I don't know what was going on Friday. It was on YouTube's side. Couldn't sustain a stream, just kept dropping frames. But right now we're at a healthy 3,000 kilobytes per second on the stream. So I graded your practicum. Practical. I've been calling them practicums. Practicum. A lab practicum is like a whole course. A lab practical is like a hands-on laboratory performance assessment. I should probably call them practicals. So I graded them and posted your grades. So now you have 2 grades on Sakai. The one for exam 1 and one for practical 1. So I've been thinking about what the next one's going to be like, and the first one was take some data and present it, and so the next one will definitely have the aspect of making a map, but it'll involve more of an analysis. You'll be using some geoprocessing tools to enrich the data, to discover patterns in the data. Okay, and it'll probably be data that is well, I haven't decided yet. I was going to say that it's probably data that involves either we'll continue with the theme of health data, or I have some interesting data that deals with crime data. But it's just interesting to do this. You guys are all pretty much interested in environmental data, and it's just interesting to see that GIS can be applied to data from the social sciences as well. All right, guys. So we're going to do some work in chapter. Oh, what is it? It's chapter 7 in the textbook today. So chapter 7 deals with a concept called geocoding, which is a fancy way of saying let's create features that we can map, point features usually. Let's create points that we can map that are from a list of addresses or place names. So ArcGIS Pro has some tools built in for us to be able to do this. You can also create your own, it's called a locator, to map addresses to locations, points on your map. All right, so we're going to do that. I'm reminded of something. So on the exam, there was a question which asked you what the thanks to Aaron for discovering this. There is a question which asks you to name the 3 kinds of feature classes, vector feature classes that you can have. And so vector data can be points, lines, or polygons. And when I coded that question, I was looking for those 3 words in any order: points, lines, or polygons in any order. But I will also accept singular, point, line, polygon. All right, I'll accept it if you put in that answer as singular. So if you did that and you got that question marked wrong, send me an email and I'll award you 2 points if nothing else is wrong. All right. Yeah, Aaron, smiley face with the cowboy hat. Good work. So, all right, geocoding in chapter 7. Let me switch over here to my desktop, and we'll get started with the project that is. Here it is. It's in the textbook. Make this a little bigger. How are we doing here? There, fill up the whole screen. Okay, so here it is. This is a project file that has been supplied to us by the textbook authors, and it's in a folder called Community Housing. When you open it up, what you got are let's see. There's a layer for LA census tracts, and this looks familiar, doesn't it? It looks like the data that one of the data layers that's in your project that you're working through in lab with the project workbook. So each of these polygons is a census tract, and there's all kinds of data associated with it. Let's look at the attribute table and close that. So you got state code, county code, a GeoID for each track, and then there's GeoID2, which is the same number, just without a leading 0. And this last column is going to be useful to us. Area, median income, but I want to calculate it later. So I calculated this earlier. I'm going to delete this, and we will calculate it again. Doop, bong, gone. Okay. What else do we got? We got these streets, and let's take a look at the attribute table for streets. So it's a lot of stuff that looks nonsensical. Got street name, and each of the streets of West 15th Street looks like it goes from address 301 to 399 on the left-hand side of the road, and on the right-hand side it looks like it goes from 300 to 398. So, you know, this is kind of interesting. You guys know this. You probably know this, that when it comes to street numbers, typically one side of the street is odd numbers and the other side of the street is even numbers. And so this streets data set has information like that in here, and we're going to turn this feature layer into a tool that allows us to map the locations of addresses using the information that's in this in the table associated with this layer. So you know, if you end up getting an address that's somewhere between 301 and 399 and it's odd and it's on West 15th Street, this locator will place that location on along the street that is referenced with that same range of street addresses in the streets layer. All right, so we'll get there. Okay, so all right, let's see. What do I want to do first? Let me take a look here at the project layer. So okay, so the first thing they want us to do is one of these tables that's supplied to us in the project folder is called household income. Let's add that to the map here and take a look at it. So we got household income for each of these census tracts. So what we'll do is we'll join this data to our census tracts data, and we will use one of these GeoIDs to do so. And let's see, which one makes the most sense? I'll close the streets table. I don't want that anymore. Open up the attribute table for LS census tract. So we got GeoID and GeoID2 and GeoID, GeoID2. So it looks like the GeoID, yeah, the GeoID columns aren't the same in these two data sets, but the GeoID2 columns look like they're formatted the same length numbers. So let's do a join of this household income table to the LA census tract layer on that attribute, GeoID2 and GeoID2. uh, geo.id2 in the table. All right, so you guys know how to do this. We'll add a join to LA Census Tracts, and with the input, yes. What is the table? GeoID2. All right, so I should have done it. Household income, so there it is. All right, we got it. So this household income column came from the household income data table. Okay. So nothing new there. Then we ultimately, you know, one of the themes in this chapter is trying to find correlations between a measure of income and the locations of public housing units. And what we should see is there's a correlation between the locations of public housing units and the locations of census tracts, which are low income, either extremely low income or moderately low income. So we want to introduce into our data here for the census tracts a measure of income that is sort of a ratio of the median household income in the United States. All right, so that's what we're going to do now. So in this data table, I'm going to close the household incomes table because we added it to our attribute table here. So I'll go over here and we'll do fields view, and I'll add a field. Click down here to add a field, and I'm going to call it AMI, which is short for the alias area median income, and I'll make it a double, which is a floating point number, and it's numeric in nature. It's a numerical value, and we'll report it with 2 decimal places. Click OK. All right, so I'll save that change, and then get out of the field view, and if I scroll over here, okay, there it is. So then I'm going to calculate something in this column, which is a ratio that involves the household income that I merged from the table. So I'll go to calculate field and make this a little bigger, and we'll make this household income, the value in the household income column, divided by the median household income in the I'm not sure if, I guess this is Los Angeles County. The median income in Los Angeles County is $56,000, and I'm guessing this was from a few years ago. It'll probably go up in coming years because of all the inflation that's going to happen because of all the crazy levels of spending. 46241, all right, is the median household income, and I'll click apply, and it's done. Okay, so I had this originally and I deleted. So if you look in this column, a number that's around 1 means that that census tract has a household income that's near the median. If it's less than 1, it means that that census tract is less than, is poorer than the median household income. And if it's greater than 1, that means that that census tract is greater than the median housing income. Okay, so let's say, here we come back here. Let me ask you a question. Let's get a little bit more interactive here. Make you guys think. All right. So if I want to just make a map of the census tracts in LA County, and I want to have that map represent the degree of income, low income to high income, and I have these values now, area, median income, AMI. What kind of map should I make? What do you guys say? I want to show you just, the power of visual presentation is that our visual system is just so powerful when it comes to the ability to just look at information and understand, to see patterns. We are pattern recognition entities. So much of what we do is just pattern recognition. The world is way more complicated than we can possibly make sense of. So via evolutionary pressure, we've developed the ability to see patterns, and there's a lot of negative baggage that goes along with that. But we're really good at finding patterns. We find patterns even when there's no patterns there. That's how good we are at finding patterns. So what kind of map should we make? What kind of map should I make here? I want to show, I want something that I can look at and instantly look at that map and see which census tracts are high income and which census tracts are low income. Do you need a clue? So in your practical exam, your goal was to create a map that the user could look at and immediately see where high cancer incident rates were and low cancer incident rates were. What am I getting at? What am I driving at here? What kind of map are you going to make? You guys are... This is like my grandma would have said, this is like pulling teeth. Come on. Give me some guesses. What kind of map? Thank you, Gracie. Thank you. A choropleth. Yes, Cam. Right. A choropleth. Good. I'm guessing you guys got that question right on the exam. Okay. A choropleth map. Let's do that. So, or in other words, let's apply a symbology which uses graduated colors. All right, and graduated colors apply to, I'm going to turn the streets off. So not single symbol, let's do graduated colors. And what's something more dramatic if we want to show? I guess with income, it's like high income good, low income bad, or something like that. So let me zoom out here. Zoom to the layer. And we want to use our area median. There we go. Okay. So when it comes to something like this, your best bet is to symbolize with 5 classes. We'll do 5 classes, but instead of using natural breaks, let's do manual intervals. Okay, so now, and another thing is, if you look here, that we're going from big, low to high, and low is, so it's kind of like low income. If we think red means warning, warning, and in this case, low income might be the thing that we're trying to accentuate in a way. So we probably don't want a color scheme that goes from light yellow to red. We want the opposite. So in the more menu, you can't see that. It's going. I know it's going off the screen, but if you click more, one of the options down here is reverse symbol order. Here we go. You can also, let's do this. Let's format all these symbols and give it an outline color that's different. The textbook likes this one, soapstone. I love these colors. You guys can't see this, but it's like a Sherwin-Williams story here. All these colors, they have such beautiful names. Soapstone dust. Soapstone dust. It just sounds so beautiful. All right. And okay, so but I want to hard code these values here, and according to the values that the textbook is telling me are important. Maybe these are values that are actually used by government agencies, for example. So for the low income, we're going to say anything below. Oops. I screwed that up. 0.5. Anything below 0.5 is. Oh, you know what? Let's do something else here. Let me. I'll just leave that open, and let's go back to the attribute table. And how do you get something that's a? These are sort of like percentages of income. So let's modify this a little bit and make it so we'll divide by 52,000. What was it? 56,241. And then we'll multiply by 100 to get a percentage. There we go. And all right, close that. And now we'll come over here and do manual intervals. So anything less than 50 is, we'll code a label here of very low income. And then anything less than 80 we'll code as being low income. And anything less than 120 we'll code as moderate, which would be like average. And anything, shoot, I screwed this up. It should be 30, 50. 30 is extremely low income. 50 is very low income. I forgot that lowest level. Man, 30% of median house, that's very, very low income. Less than 80 is low income. Less than 120% of median is moderate. And then let's see, the highest number in our data set here is 411.88, so we'll make that 412. And we'll call that high income. It'll be interesting to explore what counties have incomes that are 400% higher than the median. There's a county right here in the middle. What's that? What's going on there? Our census tract. 155% of median income right next to these census tracts, which are extremely poor, less than 30. It's crazy. I wonder what's going on right there. Okay. So if you look at my one of the things you guys should pay more attention to next time you do a practical exam, and also in your projects at the end of the semester, is excuse me, pay attention to what what the text in your legend is saying. Make sure it's descriptive. Make sure it's informative. Make sure it's clear. So, I guess that wasn't really something I would have emphasized in terms of of all the things that I was looking for in your practical. That was pretty minor, but it's important. It's important if you're going to share your data. If you If you don't, um, if you don't pay attention to whether or not the labels that you're using are descriptive and they're clear, you're just going to miss your mark. People aren't going to use your data. They're not going to be able to really make sense of what you're showing them. Um, if you guys know that, like, people's attention spans are really short, and you have, when people are looking at new novel stuff, those first like 10 seconds are extremely important. And so this is one of the reasons why visuals are so powerful and maps are so powerful, because you look at this, and let me zoom to extent. You think about, this is hundreds of data points. Hundreds. Let me zoom in a little bit here to the middle of LA. That's hundreds of data points, and you look at that and you see patterns right away. And me, I look at that and I see an aberration. I see this wealthy census tract right here next to these very poor ones. And I think, what the heck is going on there? But look how powerful that is. All that information gets distilled into a message that's just sort of visceral. You see a pattern, okay? You see that there's clusters of low income census tracts here in this area of LA. All right, so I'm paying attention to my labels here. You might think, we're scientists and we like to think of data as numbers and ranges, but most people are, if you I know I'm digressing here a little bit here, but I find this really interesting. If you have on your map, what do we have here? Area median income, and then one of your classes is less than 30. Like, people will see that and like, okay, well, that's less than 30 and it's red colored. Now compare that to seeing the same thing, but instead of a number, it says extremely low income. And you tell me which one is more informative or communicates better. And you might say, well, that's extremely low income or words. It's subjective. Numbers are hard. They mean the same to everyone. And what I'd say to that is, well, are you trying to be persuasive? Because if you are, you understand that people are pretty subjective entities. Okay. So, all right. Back to the map here. Let's see, what's next? Okay, so we got our census tracts chloropleth. Is that a verb? We chloropleth our census tracts, and with household income, and so now we're gonna get the geocoding, and let's go to let's see. All right, where's the tools? Sorry, analysis tools. We'll go into the toolboxes here. One of the toolboxes is called Geocoding tools. We'll look in there. And there's a tool here called Create Address Locator. I think it's in here. Yeah, there it is. Create Address Locator. So we'll click on that and take a look at this tool. And the address locator style, there's lots of options here. We're going to use the option for dual range, and let me just check here, see if that's what they want us to do. Yes, they do. And so we'll click on that. And our reference data is what's in this streets layer, which isn't visualized right now, and the role of that's the primary table. So when we do that, this field map pops up, and you see that there's all these different fields associated with this type of address locator, U.S. address dual ranges. And some of them are automatically populated. So you can see there's, let's go back here and look at this attribute table. And let's see, L left row, whatever I think that stands for. Let's find it in here. Okay, so you got this column from left to left. That's like saying that's the left side of the street. So it's saying that we're going to create a locator that codes addresses that we give it, numerical addresses we give it, to be either on the left or the right-hand side of the road, and its location along that road is going to be sort of proportional between the range of values, on the range of values that we're specifying here. So if I try to code create a feature from an address that is like, let's make something up here, 373 West 15th Street, it's going to put that, it's going to create a feature on the map on West 17th Street that's somewhere between the beginning and the end of that line that represents that street, proportional to how 373 is from 301 to 399. All right, what else do we got here? Well, there's a bunch of stuff here that's needed. The star things are needed. Street name, his name, full street name, full name. So a lot of this stuff has been identified for us. And let's fill in a few extra details here that weren't automatically filled in for us. So prefix direction, you know, that's like streets have northwest, south, east type designation. So there's a column in this streets data table, attribute table, that is this sort of thing, prefix direction. It's called PREDIR. Let's find it. There it is, abbreviation. Okay. Prefix type. There's a row, a column in here that does that. It's prefix type abbreviation. There we go. Suffix type. So I guess that would be like 137 King Street Northwest, or something like that. So here's suffix direction type. There it is, type abbreviation. So I'm matching up. The textbook is telling me this. You can imagine if you weren't told this, this might take some work to actually figure out what columns in the attribute table match up with these different field names in this address locator that we are creating. Suffix direction is direction abbreviation. All right, and so let's create a let's name our creator in our. It's going to be saved. This address locator is going to be saved in our project folder, and let's call it housing address locator. Locator. There we go. And I'll save it, and we're ready to go. So I'll run this and let's see what happens. Let's see, this might take a little while. There's a lot of processing going on here. It's got tens of thousands of records to go through. All right. So it's going to take a while. All right, it's at 2%. It's going to take a while. So what it's doing right now is it's taking all of that data that's in that streets layer, and it's creating a this locator tool then will become what's a good analogy? It's sort of like a decoder for now when I pass it an address, it'll decode that address and figure out where it's located on the map, which street it's located on. So when you guys are doing, you type an address into Google Maps. Google Maps is using a tool that's very much like this to find out where that that address is located on the map. Let's see how we're doing. This might take a while. I should have shouldn't have I shouldn't have deleted the one I already made. I should have kept it so we could just skip ahead. All right. Well, while that's going, do you guys have any questions about the grades that you got back this weekend? I'm not sure if the exam is open to you yet. I think it is. I think it's open to you now, which means that you should be able to go and view the exam and see the correct answers. So it's worth your time to do that, I think. You guys should be able to view, there's a rubric that I created for the practical, and you should be able to view that next to your grade so you can see more feedback about what you did well, what needed improvement. All right, how are we doing? It's done. All right, so if I go to my catalog, I should see, let's see, in locators, there's housing address locator. There is a another locator that's supplied by Esri called ArcGIS World Geocoding Service, and the activity in this chapter doesn't have you use that one. It has you create your own locator and then use it. But it's interesting. What we'll do is we'll compare results between what we get using our custom-made locator that we made from the streets data, and we'll compare it to what ArcGIS's built-in locator does. And so we should, in an ideal world, we'd get exactly the same result. Will we? No, we won't, but we should be able to get close things. Cam's got a question. The one fill in the blank with 4 blanks had a similar problem as the other one. I put shapes and it was looking for shape. Shoot, I can't remember. It's funny when you're coding these questions, because you got to try to anticipate what you guys are going to put in. So this is Cam, can you send me an email and include the full text of the question, and then I'll take a look and see what's going on. All right. All right. Okay, so but now let's use our locator here that we created, and what we need data that we can pass to our locator, and it's supplied to us here somewhere. There it is, public housing sites. Let's add this to the map and take a look at this. So if we open this, what we got are, how many are there? 91 rows in this table. Each row corresponds to a public housing location, a building, a complex, and what do we got? One of our columns is address, and we got a column for state, city, zip code. Unlike West Virginia, which has like one zip code for half the state, the city of LA has like many zip codes in the one city. Units, that must be like the number of apartments. And the organization, the infamous Skid Row Housing Trust. Here's one I've never heard of: SRO Housing Corporation, Good Shepherd Center, the Housing Authority of the City of Los Angeles. Okay, so we got, oh, there's some other stuff here too: walk score, transit score. Interestingly, they give us latitude and longitude, so we could use the XY point tool to plot where these housing projects are. But we're not going to do that. We're going to use our geolocator, or our geocode address locator that we created. And all right, so we want to what's the easiest way to do this? I think if we right click on this, yeah. So if we right click on this table, one of the options is to geocode the table. So we can turn this table into features on a feature layer on our map, a feature class that we can then put as a layer on our map. So let's pick geocode the table, and what we got here? Well, we got some explanation of what's going to happen next. Step 1, about your table. Look at your data to determine how many fields in your data you want to use for geocoding. Step 2, what locator are you using? Decide whether to use the World Geocoding Service or a custom one that we created, which is what we're going to do here first. Step 3, mapping the fields in your table. Look at the fields in your data and the fields in your locator to see how they connect. Step 4, pick output, and then there's some optional steps. So let's go to the tool here. The input table is this public housing sites, and the locator we're going to use is this one we created, housing address locator. And there's multiple fields. We'll use the street or intersection, the address column for street or intersection, and the zip code, the zip column for zip code. Alright, and then we'll output our results in, let's create public housing sites custom for our custom, because we're using our custom locator here. And then we'll add the output to the map after completion and run. Alright, let's see what happens here. Geocoding complete. So it got 87 matches, and it looks like 3 of the rows were unmatched, which means they couldn't find a suitable location for those addresses. And there's a couple of reasons that might happen. One reason is maybe there's a typing error, a spelling error. So maybe like the street name is misspelled, or maybe the street number is incorrect. What else could happen? There could be like ambiguous cases. One place that comes to mind is, have any of you ever been to Atlanta, Georgia? And Atlanta, Georgia, is it Atlanta or Atlanta, Georgia? I'm pretty sure it's Atlanta. There's like Peachtree Street, Peachtree Road, and then there's another Peachtree Street, and then there's another Peachtree Boulevard. There's like 83 Peachtree Streets, so you can imagine there'd be some ambiguous situations that emerge when you have like 50 streets that are named after Peachtree. But in this case, okay, start the rematch process. Yeah, let's do that. So we'll start the rematch process. So this is like sort of like Sorry, I clicked on a button and said start research match process. And so we do this. You can see like we've got 87 records matched, 1 tied, and 3 unmatched. And zoom out here. I'm going to turn off this census tracks data here. All right, so one of them that's unmatched here is 52089 San Julian Street, or Julian, depending on your pronunciation. And let's see what's going on here. So this is an example where the street name is there's a typo here. It's not 52089, it's 520. So there's a problem. And when I fix that, you'll see that there's these 2 candidates that pop up. And so now in my locator, I found 2 candidate street addresses. This first one, 520, gets a score of 100, and this other one gets 79. So here is here's these 2 candidate locations. So which one are we going to pick? Well, let's take a little closer look. I think there we go. We weren't seeing the topographic layer. And let's click this one that's most close to it. So what is this? Public housing site. So this is, let's select this one. It's 518, and what's this one? 506. So which one's closer? So anyways, well, now what happened here? I didn't want to do that. Crud. Clear. All right, now we're back. So this is 518 and this is 5 something. So it seems like this is probably 520. And so this, yeah, let me see if I can do this again. Let me change. I'm going to be able to zoom in here a little bit more. I want to be able to zoom in and be able to see the topographic information. So I'm going to make this a small number. Now I should be able to zoom in further. Oh, shoot. Where is it? There it is. Let's make it this small value there. Now I should be able to see it as I zoom in. There we go. Now I can see as I zoom in. Okay, so here's our unknown location, and we got 2 candidates here, and it looks like it's on the same side of the street as this one, which is an even number. Okay, so it makes the most sense that we would pick the even number. All right, 520. It's on this. We know what this one is. It's 518, so this is probably 520. It's an even number. If it was an odd number, it would be on the other side of the street. All right, so we're going to pick this one and do check mark, and then that matches. Okay, so now we have one more matched feature, and our unmatched features are less. All right, so our next one is, looks like this might be a spelling error too. Maybe it's just that capital T. Nope, that didn't find anything. Well, let's try to find this using, you can click this button up here, find locations by typing in an address, and let's see what we come up with if we just start typing 417 East 7th Street, and yeah, Los Angeles, California 90014. And so the ArcGIS World Geocoding Service found a location for us. And shoot, gotta go back to my pane here. And maybe I'll just do this. All right, and what do we find? 417. So there is a location, 417 East 7th Street, Los Angeles, California, 90014. And, well, that's good. We can use that. So we go back here and we see the zip code's missing. So if I add that, will it help? 90014. Let's see what we get. Yeah. All right, so we got two candidate locations. 417 East 7th Street and 417 West 7th Street. Well, obviously it's the first one. This matches, this location in our locator matches the address given, so we'll pick that one. All right, we got one more unmatched, and here this is a spelling mistake because there is no Marionwood. There is a Marionwood Drive. Marion. All right, so what we got? We got two matching addresses. One's on the left-hand side, one's on the right-hand side. And we want the one on the left-hand side of the street. Okay. And then what else? So now we've matched 90 of our addresses, and then we have this one tied. What the heck is going on here? We got 1104 Browning Boulevard, and there's all these candidate sites. Let's see if I can view them all. So if I click here and do zoom to all, it shows me all the sites, and there's A, B. Where the heck is C? C must be, C is under A. So A's been matched to this location, but it's saying that there's ties here, and there's two addresses, A and B, that have exactly the same location, or exactly the same address according to our locator. All right, so I was hoping to get through this today, but I'm not going to. So we'll pick it up with this next time, and we'll resolve this last tied one, and then we'll move on to the next part of this activity. All right, so I'll see you guys on Wednesday, and have a good day.